And then we'll do the second part of 1.5 on Friday after your test. Okay. So the first part of 1.5 has to do with parametric equations. Okay? So let me put a couple of examples up here. I don't know if you've ever seen anything like this before. This is a system of parametric equations. And what parametric equations are used for, or used in situations like this. Remember our projectile motion, where we threw the ball up into the air? There were really 3 coordinates involved with that. Victoria, you paying attention? Okay. There were 3 coordinates involved with that, or 3 variables involved with that. There was time, there was x, and there was y. So what the parametric equations allow you to do is, at a certain time, let's say, it doesn't have to be time, but that is a good example. At a certain time, we can determine the x coordinate and the y coordinate individually. So parametric equations allow us to consider 3 variables, time, x, and y, for example. So if somebody says, let's say this describes some object somewhere. If somebody says, where is this thing when t equals 3? That's easy. All you do is what? Plug in 3. So when t is 3, x would be 8, and y would also be 8? Coincidence? Is that okay? So that's easy. Sometimes, though, we would prefer not to have all these equations. Your book says something like, write a single equation by eliminating the parameter. Don't let the vocabulary confuse you. This is the parameter. These are called parametric equations, and t is the parameter. So if we want to write a single equation by eliminating the parameter, do you have any idea how we might put these two together? It is not hard.
What you do is
Okay, what do you mean by combine like terms?
I have a question. Is the whole equation the parameter?
No, no, t is the parameter.
Just t. Okay.
These are called parametric equations.
Okay.
Okay, we want to eliminate the parameter. I want to get rid of the t's. Any idea how to get rid of the t's? Dan?
I'm not exactly sure. You do like times like one of them by 3 on the top and like 5 on the bottom.
Oh. Well, I've never thought of that before, but let's try that, Dan. Okay. You see what he's saying?
Like what you do when you
He's saying like regular elimination, the process of elimination. Now, when we do normal elimination, we usually just have x's and y's, but you're saying use that principle. So we would multiply our top equation by 3 and our bottom equation by 5. Does everybody kind of see what's going on here? You've done this before. So the top equation would be 3x equals negative 21 plus 15t, and 5y equals 85 minus 15t. Now we're going to add them together, so he has 3x plus 5y over here equal to 64. It's pretty slick. Yeah, that's not a bad idea at all. Did everybody follow that? Notice we have a single equation left, right? And is there any parameter in it? Is the parameter there anymore? Nope, he eliminated that by adding those together. That is great. That will work until, let me see if there's another example here in the book I can steal. What if we had one like this, Dan, or anybody? Okay, so is everybody okay? I'm going to erase this, okay? So what if we had a system of parametric equations like this one? That's going to be problematic, isn't it? Because they're not just nice, neat little t's. As long as they're nice, neat little t's, this is going to be perfect. Here's a system of parametric equations, and just like before, if I said, let's let t equals 3, could you find the x and the y? Just because the equations are more complicated doesn't make any difference. X would be what? 27 minus 12, 15. And y would be the square root of 4 or 2. That part's easy. Now, do you have an idea how you might take these two equations, though, and write one equation from them?
Take the 2 and plug it back into the y. Well, I guess no.
If you did that, you'd be solving for t. So actually, Blake, there are times when you want to do this. For example, sometimes we use this, let's say we've got 2 airplanes traveling, and we want to know when they might collide. Well, then we would be interested in the t, and finding the t. So we might do what you're talking about in a situation like that, but not to eliminate the parameter. We wouldn't do that. Anybody have another idea? I like Dan's thought process. He said, let's use elimination. What's the other process? Same, if you're taking first year algebra, one day you do elimination and the next day you do what? Substitution. Could we do some substitution here? Let's square both sides of this equation. We're going to square both sides of this one right here. So we'd have y squared equals t plus 1. You see where I'm going with this? What's t equal? Y squared minus 1. Now what do you think I'm going to do with this y squared minus 1? I'm going to plug it in right here. So what will x equal? X will equal y squared minus 1 cubed minus 4 times y squared minus 1. Now that is a very unpleasant equation. I'm not going to FOIL it all out and all that stuff, because that's what this would be, right, is a big FOIL. I'm not going to do all that. I want you to look at the equation, though. Did I follow my directions? I erased my directions, but what were my directions? Write a single equation with no t's. Do I have a single equation with no t's? Yes.
Would that be the answer?
Yep.
So you can leave it like that?
Well, this one I'm going to, because I don't want to have to FOIL out this thing 3 times. If that had only been a squared, I probably would simplify, but I'm not going to take the time. Okay. All right, so enough of that. So parametric, this is the basic parametric equations. One quick comment. Go to your calculators. I want to go back to this first example here. You can actually put, we're going to use this example here, you can actually put parametric equations in your calculator. I need you to go to mode, find mode. Mode is in the top row buttons, right? And notice, if you go down the list there, probably highlighted now is function, F-U-N-C. Well, what's right next to it? PAR. And what do you think PAR stands for? Parametric. So let's click over there and highlight that. Now press Y equals. Uh-oh. What's it asking you for now when you press Y equals? An X and a Y. So you would put in this and this. Now, I want you to look at your variable button. Remember where we get the X, where we put an X in? What's right next to the X? So now, when you press that button, a T is going to come up. Okay? Now, just keep that in the back of your mind. Now I need everybody to go back to mode and switch it back to function. Otherwise tomorrow you're gonna be all messed up. Okay, so everybody's back in function mode. But remember, if you need or want to graph parametrically, you have that capability by changing the mode on your calculator. Dan,
So are we gonna be able to use our calculators like this tomorrow?
part of it,
Oh, it's a
just like the
calculator,
last
okay.
one. Or at least that's my intention, I'm not quite done putting it all. All right, speaking of that, all right, now we are going to get our quizzes back. And we're going to have some conversation about it. We're gonna do this a little bit differently. There are really two big blocks of things I want to do, and that is the first problem, which was the holes and asymptotes and all that. The domain problems, and then there's everything else. So everything else on the quiz, we're gonna stay as a group and talk about. Then, only those people who need to focus on that first problem are gonna stay in the room. The rest of you are gonna go out in the hall and work on homework, or go over to the side or something and work on homework. Then we're gonna, anybody who needs to do domain is gonna stay in here with me, and everybody else can go be working on homework. Due tomorrow. No ifs, ands, or buts, and I'm going to email parents if you don't turn this in, unless you get an A+ on the test. Due tomorrow, review sheet 1, which is in your packet, review sheet 2, which is in your packet, and the assigned book problems that are on Schoology. Okay? So that's due tomorrow. So you may work on that after we go over the main part of the test here, the quiz here.
I did 1 through 40 on the review. I didn't know if it was find problems or
You did 1 through 40?
not. Yeah, is
Well,
that,
then you did some extras. Good for you.
I couldn't get school to level. I was gonna do 1 through college until we something I don't know how to do. How many were we supposed to do? Like 20?
It wasn't that many.
Oh.
But that's okay.
It was like 1 through 10.
That's okay.
and like 11
I did
through
1 through
39
40.
on.
That was obvious.
Oh my god.
Think how good you are,
I'm feeling
how
great.
well prepared you are. Reagan. Blake.
Which is it? Wait, what was that again?
But you get as always.
It's only over the first half of the chapter. This is out of 28. So some of you,
I'll show you my notes. I know how to comprehend them, and I was in the class. Okay, parametrics, where did we talk about those? So it was at 1.5. C sustained by find the inverse.
Yeah, right.
I don't know.
What are your notes mean?
Oh, this one. Now,
See,
I don't think
I have English next period. Can I give you an extended time form?
yeah, like how did, oh, really?
now on, it's this period.
Like x minus 2 or x plus 2, like what happens
I get that right. Yeah, because you have to look at
Okay, now.
No, I thought that was for A.
All right, stop. Everybody pay attention. We are looking at, would you like here? I have one you can look at. Here, you can look at this one. All right, so I'm going to look at number 3. Again, we're going to do 1 and 2. Those are huge things. We got to get this under control. So 1 and 2, we're going to do kind of individually. 3, identify the following as even or odd. First of all, somebody tell me what even means. Symmetric across the y-axis. And if you think about that, and that's what I want you guys to do, is think about it.
It only could have.
If you're symmetric about the y-axis, that means if you put in 1 and get 2, When you put in -1, you're also going to get 2, right? Across the y-axis. So you got two options as I see it on this problem. You look at y equals 3x squared plus 1, and you say to yourself, oh, BFF, that's quadratic, right? What shape is it? It's a parabola, right? It's been moved up 1 unit. So it looks like this. So if you can think about that, if you can process that, look at that picture. Is that symmetric about the y-axis? Yes, so it's even. Now, if you can't process that, if that doesn't make sense to you, then put a number in. Put 2 in. If you put 2 in, what do you get? 13. What happens if you put in -2? You still get 13. Plot those 2 points, kids. Aren't they symmetric across the y-axis? You can figure it out. Now, what about the next one?
33.
You can graph it. You don't even need to graph it. You can visualize the graph. Doesn't it look like this? Oops, it's supposed to go through the origin. Doesn't it look like this?
Yep.
Goes through the origin with a slope of 8. Now, what does it mean to be symmetric, or what's it mean to be odd?
Symmetric.
About the origin. That means the points in quadrant 1, look at your equation, this is the point 1, 8, become quadrant 3, -1, -8. Isn't that what oddness means? So you can either look at the picture or you can look at specific points again to tell. That is odd. All right, next side. Some of you just, I think, simply didn't read the question. What is the name of the curve shown in C? If you said reciprocal, I think you were looking at A.
I did.
What is the name of the curve shown in C? It's the square root function. What is the domain of the function in B? What's the domain? X is greater than 0. Kids, domain is the x values. Which function is this, by the way? Natural logarithmic function, yeah. And this is an asymptote, so we never get there, but we get infinitely close, so x is greater than 0 is your domain. What is the range of the function in A? This was the hardest one in this set. What is the range? If you said all real numbers, you were very, very close. Be careful though, there's a horizontal asymptote at 0. So y will either be bigger than 0 or less than 0. So you could say y is greater than 0 or y is less than 0, or you could say y is not 0. Either one of those would be okay. Some of you said x. Remember, it is a range question, so we shouldn't be using x's. Bailey?
If you put the y is greater than 0, do you have to put also the y is less than 0 too?
You do, because you have y's that are positive and you have y's that are negative, right? Yeah, you need the whole thing. Okay, and then the cubing function, everybody got. The bonus, not very many people got that. The function in A, we want the limit as x approaches infinity. That's out here. And the function in A looked like this. What's happening to the y values? What's happening to y as x heads toward positive infinity? What's happening to these y values? They're getting closer to 0. And I would have given an extra special bonus point if you did that. What does that mean? We're getting closer to 0 from the top. Because could you have a picture that got closer to 0 from the bottom? That best describes the behavior. You're approaching 0 from the top of the curve. All right, are there any questions about those things then? All right, if you missed any points at all on question number 1, you're staying right here or moving over here or something, because we're gonna go through that with a fine-tooth comb. If you did not miss anything from question number 1, you may stay where you are and work on homework. You may go out in the hall and work on homework. You can move over to that side of the room. I don't care. But if you missed anything on problem 1, you are here. What, Taylor?
I made like a really stupid mistake, and I know what I did wrong.
Yeah, I did too.
So you missed one teensy-tiny little thing in problem number 1.
Yeah, I missed times.
All right, you make the
times
call.
3 and a half.
Okay. The idea is you need to know how to do problem 1. If you feel confident you know how to do it, then you can tune me out.
So the homework is in the red for the book problems is the 3 through 15, 16 through 20. And what about the,
I just mixed up my points.
the 21 through 42? That one's
Okay. Now, if you want to get up and move, you can. If you are staying in the room, you cannot talk, because everybody's beady-little eyes need to be focused on me and your ears need to be tuned in. We have got to get this straightened out. This is our last chance before tomorrow. Okay, step 1. We are going to factor anything that factors. Okay, so look at the top. What can we do up there? Take out a 3. So I'm going to start by taking out a 3. All right, what do you notice now about what's left after you take out the 3? It factors into x minus 4 plus 1. Very good. And how about the bottom?
X plus 1.
And then your little hearts go pitter-patter because something cancels. And the problem reduces to 3x minus 4 over x minus 1, correct? Now, you are supposed to be telling me the wholes, the intercepts, and the asymptotes. Right? Okay, here we go. We had a cancellation. That automatically means there's going to be a hole. Holes happen under one circumstance: something cancels. If nothing cancels, there's no hole. You cancel. The hole is a point. For Pete's sake, I even wrote point to remind you. What is the x-coordinate of the point? -1. The x-coordinate comes directly from the thing you canceled out. So your hole has an x-coordinate of -1. Now, in any math class anywhere on the planet, if you know x, how do you find y? Plug it in. That's how it's done. That's how you build a t-chart. That's what you do. So if you know x is -1, we're going to plug it in right here and figure out what y is. So we have 3 times -1 minus 4 over -1 minus 1. So what have we got on the top? -15 over -2. So my y coordinate is 15 halves. Is there anybody that's confused at this point? Now, this is like a wedding. You speak now or forever hold your peace, people. Okay. Now, let's look at what we've got left here. This is our problem now. Are there any vertical asymptotes? Yes. Where do vertical asymptotes come from? Denominator equals 0. So what would make my denominator 0? What makes my denominator 0? 1. So my vertical asymptote is x equals 1. Now what about my horizontal asymptote? You can look at the original problem if that's easier. You can look right here. Or you can look at your pencil problem, look right here. Either way, where's the horizontal asymptote? Y equals 3. Now some of us are still mixing up our letters. You guys, if it is a vertical line, which axis does it cross? X, so it's an X equals. If it's a horizontal line, which axis does it cross? Y, so it's a Y equals. Now we need intercepts. This should not be hard. Stop a minute and think. Just think, I want a Y-intercept. What do I know about any point on the Y-axis? You know something about it.
The
X
is 0.
is 0. If I were to plot this point, it would be 0 comma something, right? So once again, if I know X is 0, how am I going to find Y? Plug 0 in. And when I plug 0 in, I get 12. Plugging 0 into my problem. Just plugging it in and working it out. Now, how about my X-intercept? Well, it's somewhere here, right? What do I know about this point? If I were to plot this point, it's something, comma, 0, right? So Y is 0, so coming back to my equation, 0 equals 3x minus 4 over x minus 1. So if I multiply this over to here, what's this become? I'm going to multiply both sides by x minus 1, kids. Some of us are having trouble solving this. What do I have over here? 0. So what does x equal? What is my x-intercept? 4. So there's my x-intercept. Now, does anybody have a question about that? There is one of these on review 1, and there's one of these on review 2. I would strongly suggest that even if you've already done them, if you miss this, you go back and do one of those again and make sure you can do it completely without looking at the answers. Emma?
Going back to the horizontal asymptote, does it matter where you solve it from if you do it from the top of the, if you do it from the unfactored?
No.
Okay.
Anything, actually, Emma, anything associated with y, which would be the horizontal asymptote or the y-intercept, can be found from the original problem.
Okay.
Anything associated with x, which would be the x-intercepts, the holes, and the verticals, have to come from the reduced problem. So I generally find everything from the reduced, but you can do the y-intercept and the horizontal asymptote from here.
That's what I did.
Yep, that will always work. All right, good on that? Okay, now, anybody who missed anything in number 2 needs to stay put, pay attention, listen. If you didn't miss anything in number 2, then you are free to go work on homework, that is math homework, practice, or whatever, okay? So now we're going to do our domain questions. Domain. What are the 2 rules? Some of us haven't learned these yet, and I don't know what to do about that.
Square roots is the fraction.
So if we have a radical, if we have a fraction, we have to be on the lookout. What's the rule for a radical?
It's whatever's like set as less than.
Whatever is under the radical has to be greater than or equal to 0. Okay, kids? Just know that, and you're home free. What's the other one? What about a fraction? What's the issue with a fraction? The denominator cannot be 0. So when I look at problem A, I don't understand how I can miss this. Because problem A does not have a radical, so I don't worry about this. But problem A has a fraction. So what's my rule? Whatever is in the denominator cannot be 0, which means x cannot be -4. Period. Stop. That's the answer. Look at B. It does not have a fraction, so I don't have to worry about that. But it does have a radical. So whatever is under the radical has to be bigger than or equal to 0, which means x has to be bigger than or equal to -2. Period. C has a fraction and a radical. So whatever is under the radical has to be bigger than or equal to 0, so x has to be bigger than or equal to 3. And whatever is in the denominator cannot be 0. Now, does this factor?
Yeah.
No, some of you did. Wrong. Doesn't factor. Remember, if you want to try something, that's okay, but FOIL it back together and see if it works. It won't. Could I subtract 4 and take the square root? I absolutely could, but what's going to happen when I do that? We are keeping it real, folks. We are not interested in imaginaries. Not interested in, never have been. Can this denominator ever equal 0? Can you square something and add 4 and get 0? It's not possible. So I don't have to worry about it. It won't be 0. So what's the answer to the question? X is greater than or equal to 3. Now, does anybody have a question about domain?
Yeah, that quiz back so I can give it to the kid at Walmart.
Emma?
So when we're doing the ones with just a fraction but no radical, the top half doesn't matter. The numerator doesn't matter.
No.
Okay.
No.
Like, say, 2, 4, plus 4.
If all you have to remember are these two things, that's it. All right, so we're good on domain? Okay. Katie, would you go out, are there people out there, would you go get them and tell them to come in now, because we're gonna do a group review? Thank you.
Is this different from any of the reviews you've done?
No, what I'm gonna do now is whatever you want me to do. Tomorrow is your test. Some of you are in desperate need of some points. So, what on review 1 or 2 have you had a question about? Mahela?
On review 2, number 5.
Review 2, number 5. Oh, this is kind of like a problem out of chapter 1, or I mean P, chapter P. We spent a lot of time in chapter P solving equations. Many of them were quadratic. So we had, okay, quadratic formula and all that stuff. This is not a quadratic. So let's think about how we solved equations back in chapter P. Quadratic formula won't work. Completing the square, not a square, won't work. What was our other option? We could complete the square, we could use the quadratic formula, what else could we do? Factor. Now, will this factor? Now, maybe not in the traditional sense of how we would factor a quadratic, but can you factor something with this many terms? By grouping. So let's take a look at that. Let's take the first 2 terms and we can take out an x squared. And what can I pull out of the last 2? -9. When you pull out the -9, that leaves you with x plus 2. We talked about this back in chapter P. If you're going to use this strategy, which is an awesome strategy, these have to match, right? They do, so I write them down. Please note, I don't write it twice, I don't square it, I just write it down. And then I'm left with x squared minus 9, which factors itself into Yep. And so what are the answers to the problem then? -2, -3, and 3. Emma? Is there one on this sheet? Yeah. 15. Let's do 15. You will have to graph a piecewise function tomorrow. So our first piece is x plus 1. What's x plus 1, Emma? What shape is x plus 1? It's a line, slope 1 going through 0, 1. So there's a picture of the first shape, but I'm only interested in x's that are less than -2. So I'm going to put an open circle where x is -2. I'm going to put an open circle. And then I want to be less than that. So I'm going to erase all of this. Does that make sense to everyone? Now let's skip down to the bottom. The bottom says x squared. What shape is x squared? That's your parabola. So that would look like this. But I don't want the whole parabola. I want only the part where x is greater than -2. So here's where x equals -2. And I want only the part where x is greater than that. So I'm going to erase this part of the graph. Does that make sense to everybody? And then what's that middle part say? X is -2 and y is 5. What's that? That's a point right there. Vincent?
We do 4A on review 1.
Yep. So Emma, you good on that now?
Yeah.
You okay with that? Just for fun, while we have it, let's talk about domain and range of this guy. What's the domain of this picture? All reals. Absolutely, it's outlined right there. What's the range? Be careful. Is it heading up into space? Is it heading down into space? But it's not all real numbers because why? We've got a space in here, right? So all the y's greater than or equal to 0. Everybody good with that? And then where do we start again? All the y's less than -1. Open dot, going down. Okay, number 4 on review 1. Which one on number 4?
A.
A. 4A on review 1. This is another one like Mahela asked about. It's a solve problem out of chapter P. Only it's not as big as Mahela's. This is a quadratic equation. So what do we want to do with a quadratic equation? Set it equal to 0. And then we go back to that whole list of options. You can complete the square, you can use the quadratic formula, or you can factor sometimes. So what do you want to do, Vincent?
Quadratic formula.
Okay, quadratic formula would say -b plus or minus the square root of b squared minus 4ac all over 2a. And if anybody dares say to me, oh, but Mrs. Ford, the quadratic formula is not in this chapter, I will smack you, because the quadratic formula is a part of our permanent learning. 2 or 4 plus 12, 16. So 2 plus or minus 4 over 2. So I'm going to get 2 answers. Vincent, I always get 2 answers, right, no matter how I do the problem. 2 plus 4 over 2 would be 3. 2 minus 4 over 2 would be -1. When I got this number for my discriminant, remember that word, I got a perfect square. Anybody remember what that tells me? I could have factored the problem. This is a factorable problem. It doesn't matter, we got the answer, but it could have factored. Anna?
Okay, so for number 7 on vocab for the first one, I think, I know you told us removable discount, like it's like when you don't pick up your pencil, but you told us not to write that. Is there like, what's
No,
the-
a
That's, sorry, what
discontinuity.
discontinuity?
Yeah, a discontinuity is anything in the graph that causes you to lift your pencil. Okay, a removable discontinuity is a hole.
Yeah.
Because when we factor and cancel, we remove that from the problem. A non-removable discontinuity is what we can't get rid of, which shows up as a vertical asymptote. So for our purposes, a removable discontinuity is a hole, a non-removable discontinuity is a vertical asymptote. Grace?
That it's horizontal asymptote too, right? Or no?
Horizontal asymptotes are discontinuities, but they aren't classified as removable or non-removable. Those are dealing with domain issues. Those 2 words are kind of a technical point. Don't worry about it. Robert?
So a vertical asymptote is non-removable, and a hole is removable.
Yep.
Okay.
Okay, and then Robert, think about that for a minute. How do we get holes?
Then you take them out of it.
Yep.
Okay.
Take them out of the problem, remove them.
5.
On which sheet?
On the picture.
First review sheet 5B.
Yeah, like the domain and range, but,
F of x plus g of x. So that would be 2 over x plus 2x squared. And I want the domain and range. Well, the domain is pretty easy actually, because we just talked about it over here. What do I have to worry about when I do domain? Fractions and radicals. I don't have a radical, so I'm not worried about it, but I have a fraction. And what's true about fractions? The denominator cannot equal 0. So my domain is everything except 0. Now my range, there are a couple of things I could do. First of all, if this is on the calculator part of the test, you could always type that in and draw a picture of it. See, what does it look like? I wouldn't recommend doing that too much by hand because it'll take a lot of time, but you could also sketch it by hand by plotting points. You might also, let's get a common denominator here. If we get a common denominator, we have 2 over x plus 2x squared over 1. So that would be 2 plus 2x cubed over x. Would you agree with me if I just added that together and got one term? How do I find, if I'm talking about range, I'm interested in y, how would I find a horizontal asymptote?
you would pay attention to the code.
I'd pay attention to these guys right here, right? Oh, they don't match. I don't have an x cubed on the bottom to balance out the x cubed on the top. What happens when the power on the top is bigger?
There's no horizontal.
There's no horizontal asymptote. Now wait a minute. If there's no horizontal asymptote, then that means there's nothing to break the verticalness of the picture. What I mean is, if you have a horizontal asymptote, your curve is going to do something like this, right? It's broken here. There's no y values here. If you don't have a horizontal asymptote, what does that sort of imply? It's just gonna go up and down forever and ever, right? So your range is all real numbers. That's it. That's, you know, that question is gonna distinguish A students from everybody else, right? That's not a big point of the exam, or the test, okay? I mean, it's good that we're talking about those things, but don't panic about that. Make sure you know how to find domain. Make sure you can find holes. Make sure you can graph and talk about all of your BFFs. That's the big part of the test. All right, so who else had a question about something on any of these papers? Jamie? Or the book review, if you've done that.
You found boundedness, and it's only bounded above, you say no, not bounded.
Well, it depends what the question is. If the question is about boundedness, then you say bounded above at y equals 2, or, you know, wherever it's bounded above. If the question is specifically, is this function bounded, then the answer would be no, because bounded means above and below. So you have to answer the question that's asked. Victoria?
Number 19 in the review.
19 in the book. Maybe Dan wants to, he's our book expert.
What is this?
Graph it, state whether it's continuous at x equals 0. If it's discontinuous, is it removable or non-removable? Okay. So let's take a look at this function.
So I guess I can do a little thing. So like.
All right, first of all, I can tell right off the bat,
Then you square it. So you get +1. That doesn't equal 0.
we'll take it a piece at a time. I can tell right off the bat, nothing's going to cancel. So there aren't going to be any removable discontinuities in this problem at all, because nothing canceled. I have a vertical asymptote at -2.
So you're trying to set the bottom equal to 0.
And what about a horizontal asymptote?
Equals 0, then it's just whatever it is.
Watch it.
It's not 0, it's not.
No, there isn't
There's
one.
no horizontal asymptote, right?
That'd be like the answer, but.
Do I have an x-intercept? Okay, wait a minute, how do I find x-intercepts? I let y be 0. So actually, I think I'm gonna have two x-intercepts.
To make sure it does equal 0, but.
Where will my x-intercepts be? At plus or minus the square root of 3? Which is like 1.7, or, yeah.
So it's like difference of square.
Do I have a y-intercept?
Just gonna have to plug stuff in.
How do I find y-intercept? Plug 0 in for x, and I get -3/2. Now, I need to, if I have to graph this thing, at this point, I'm gonna have to plot some more points, because I'm not exactly sure what it looks like. I got a good idea what's happening over here. I might put -1.9 into my calculator, and it's gonna come out positive, so it looks like this. And then if I put in -3, I'm just plotting points. If I put in -3, it's down here. So the thing's gonna look something like this, just by plotting some points. Now the question said, is it discontinuous at 0? Or is it continuous at 0? Now, Victoria, at 0, there is absolutely no problem. The only discontinuity in this problem happens at -2. Remember, we're either a hole or we're a vertical asymptote. Otherwise, we're continuous, okay? So there's no hole, and the vertical asymptote's at -2. So when the question says, are you continuous at 0, the answer is yes. The only place you're not continuous is at -2. I didn't need a graph to answer that question.
Okay.
Right from the beginning, I knew that I had at no discontinuity at 0, just negative 2.